day. Today we're going to focus on making sure items are still able to move with the Arbor Press. In class we showed the basics of how to bring the rack and the spur gear together and how to integrate them. So the magic number on the motion setting for the between the rack and the spur gear, what I found was the motion distance of 3.14. Now that may sound familiar. It's pi. Now I can tell you that in the previous versions of Autodesk Inventor, pi times the pitch diameter was one of the key components. So I'm thinking this motion value is very similar to that. And that would allow us to adjust and notice how the gears mesh really well. You can also edit that and suppress the motion to adjust the positioning of the spur gear and the rack so that way they interface properly. So now I was going to talk about how to bring and put in all the other components and basically ensure that they move properly. So the next step would be to create the shaft, and we talked about how to create the shaft before from the spur gear. That's what I'm going to do here. We're going to position the shaft, and then after positioning the shaft we'll cut the hole in the handle hub. Those are the key components. The keys that are placed in the keyway, not as critical, but we want to make sure that all the alignments occur with the shaft and so forth. So let's get started. We're going to go ahead and create a brand new component. So under Assemble, standard component is going to be started. The parent is going to be the Arbor Press column. We'll choose OK. The sketch that I'm going to pick is going to be on the spur gear. We're going to capture the position. And so now I'm in a sketch and I can project the hole, and then I can also project the two vertical lines as projections if we need them. But I could also just draw a circle because I've got the center point. I know that the connection point is there. I can now look at it using the back option here and zoom up. It's kind of hard to see where the slot is, but I believe the slot's over in this area. We'll tilt it slightly to see if we can get the slot. Yeah, so the slot is right in here. So we have to draw a line for the slot. So we're going to draw a line from here, bring it straight in. I'm not going to worry about the distance. I'm going to do the same thing on the other end or the other side of the slot. Again, bring it straight in, and then we'll connect the two lines across. Alright, so these two lines are connected. The distance from the center of the circle to that line is 0.09. So we'll dimension that. From the center of the circle to this line is 0.09. Now, the key is that we want to make these perpendicular. So we want to use the perpendicular constraint, and that will ensure that all those are perpendicular and square. Something isn't right because that is not perpendicular. Alright, so we're going to undo this because that did not work out the way that I wanted it to. We're going to end up having to project these lines. So let's go ahead and create project. And then draw a line. Yeah, it's easier when this is straight on. Let's see if we can trim this. Bingo. So we can trim that, then I can draw lines that go through those 2 points. If I can draw lines that can go through those 2 points, I can then connect them and dimension these from here to here. Make sure that that's 90, and make sure that this is 90. Okay, that's cool. Then I can trim this and this, and now I can put that dimension in from the line to the center of the circle at 0.09. So again, just had to do a little configuration here to make sure that this stayed square, even though it's easier when it's either on the 0, 90, 180, 270 locations. When it's at an angle, it's a little bit more difficult, but we got it. So now we've got the spur gear, and now we can finish the sketch. And component 1 is actually, we'll have to rename it here in a second, to the shaft, but we'll extrude this, and that will get extruded out 2.7. And so now we have a shaft, and that shaft is now based on the spur gear, which is awesome. Alright, so now we can put a joint on the shaft, and we can set this joint on the shaft, on the end of this shaft here, to the end of the spur gear position. Oof, that's not good, it rotated. So but that's one of the things that we have to deal with, is sometimes it rotates and locates itself. So this, let me undo that. Now we could look at this, and position wise I can align these two. So the joint is going to be here in the center, or I can put this line here and this point here, and that's not going to work well. But that works perfectly. So the shaft, we have to position it, and adding the joint constraint on the end would accomplish this. And then it's a matter of adjusting the position and the rotation. So it's somewhere between 115 and 120 degrees. So negative negative 117 and a half, because again, the other option is that we could align it using these sides, and that's the other thing that I'm thinking about here. Instead of using that, in this case it's 117 and a half, and that aligns it, so that sets that up. Now that moves it to all one side with that shaft. However, what we'll do is adjust this assembly constraint, and we can edit this, and that's 117.5. We can then move this the distance that we need, like a -1 inch out, and that gives us some space on both sides, and we can adjust that equally. The next step is to put the handle hub, or take the handle hub and put it on the position that it needs to be. Now, to be honest with you, we're missing a bearing, or a plate, bearing plate I think it's called, that basically seals this area, and that mounts on top of that. I'm going to mount this directly to this hole, so it's the same concept but just a little bit different in that process. So in essence, what we're going to do is take and do a joint on the center of the handle hub and the center of the handle hub. We want to basically positioned it exactly where we needed it to be on the end of the at the face of the column. So now the handle hub, I'm going to have to project and edit the handle hub. So I need to edit the handle hub in place, and now you can see why it's important to work with this, because you'll need to adjust the names on these so that way it pops up properly. Untitled doesn't help us exactly what we're supposed to do. So we're going to put a sketch on the surface. We'll project the circular items on that. And I'm in the process of projecting each of these components. Okay, so those are what I need. The spur gear is the other half of that, so I need to project the spur gear opening. So we'll choose project and pick the top edge of the spur gear here also. So now when we flip this around and take a look at it, I now have all the lines that I need to create the opening. So now I can create the circle in the center, or I could actually just draw the lines or extend these lines out. So now I've got the lines. I can trim the interior ones here, or I can finish creating the connection points here. Okay, and then I need to draw a circle. That didn't go as planned. That did. So now we've got the circle. We'll trim the interior part of the circle here. Keep the outer edge. And that's what's going to be extrude cut, or cut through our part. So we'll finish the sketch. We'll do an extrude. We'll pick this. We'll pick this. That's going to get cut. And the distance is going to be to the object edge. And the object edge is the back plate, if I can get to it. Or it could be to the surface here. Both will work. And I choose OK. And so now I've cut that opening, and there's the space for the key. So that's ultimately what it needed to happen for this edit. And now I can finish this, the edit in place. So now that's been updated with the keyway now on the handle hub. Alright, so let's continue to look and see. So the rotation of the shaft works, but don't forget we haven't linked the shaft to the handle hub yet. So we got to put a joint in between the shaft and the handle hub. So let's undo that and set it back to where it was, because the joint that I would like to put is a surface here and a surface there. So if we use those two surfaces, it's not happy. We want to go between two faces. So face there. Simple. If we do simple, that could cause a problem, but just trying to think which is the easiest way to make this connect. Because right now it does not connect between the two, and we have to connect, and the easiest way is with the keyway here. So if we were to create a joint, it's not tangent, it's not a driven joint, it's not a motion link. So it's got to be a joint or an as-built joint, one or the other. So we can place the plane there, and that did not work well. That moved things. Did not like that. Alright, so we might need to adjust this joint and slide this joint back so that it's flush with the handle hub, which it should be anyways. Your handle hub should be the end component. So the big thing is that we could adjust that handle hub. So that way that is set. And now I can create a joint based on the center so the joint, there's 2 warnings. See now how things turned fixed, and that's not good. So if we were to suppress that, okay, that's all moving well. This I should be able to use these 2 points here. So we should be able to do a joint here. Oh, that didn't work well. So I should be able to do a joint here and here. So let's try that. So a joint there. Conflicts with the assembly relationships in the design inspect existing joints, rigid groups, or tangent relationships. So what it's telling me is that this is not a good joint, and that it will fail, is what it's telling me. So it is a trial and error, unfortunately, with joints. And so you can see that it is not going to allow us to accomplish what we need. Now we could planar ball. So let's see here. Let's go ahead and delete this joint. Okay. So when we moved that, it adjusted it away from there. So this joint, we move the handle hub out, well, again, to make room for the bearing plate. Alright, so the handle hub is not moving. Everything but the handle hub moves. And so the handle hub has got to be connected to the motion. So the handle hub's got to be a rotation. So we can do here, motion, revolute, y-axis, x-axis, z-axis. Alright. And that did not work. Okay, it's much easier than you think. So I had to do some trial and error, and I'll adjust the time accordingly, but I undid the first connection where we aligned it. We needed to do that to set the shaft positioning up, but we also needed to go back and delete it once we're finished, because what we need to do is set the face of this to the face of the shaft and then make this revolute to allow it to spin. So here's how I did it. Joint, highlight the edge of the circle, come back over, highlight the edge of the circle, make sure that the motion is set to revolute, not rigid, but it's set to revolute. When you set it to revolute in the z-axis, we can animate it, which is exactly the rotation that we need. When we choose OK, it locks the positioning up because we built it with the shaft, And now when I grab the rack, everything turns. It was a lot simpler than it needed to be, but I needed to delete that original rigid constraint, or that rigid joint that we had created for the creation of the slot for the shaft and the keyway. Whew, that was a good one. Have a great day, and we'll talk to you soon. Bye now.